Okay, today we're going to look at rational exponents. So what happens if my exponent is a fraction? And what we're going to discover is that that fraction is really code for roots. So what do I even mean by that? Well, let's say I have 3 times 3. Okay, well that's the same thing as saying 3 squared. And that's the same thing as saying 3 squared is equal to 9. Okay. And then you know from previous years and from earlier this year that when I take the square root of 9, so if I take the square root of 9, I get 3. And why is that? Because you're taking the square root of 3 squared. So we know the squaring and the square root are what undo each other. We don't normally write in that too, but same as like we don't normally say something with the exponent 1. We don't normally put a plus in front of it, whatever. Today we're going to stick the 2 in there because it helps us, because we're going to change that number. What happens, let's see what happens when I've got 3 times 3 times 3. So I've got 3 to the exponent 3. 3 times 3 times 3 gives me 27. Okay, so that's one direction. So now if I put 27 here, and I put the 3 inside the root, well, the third root of 27 is 3. And why is that? That's because 3 to the exponent 3 is 27. So the third root undoes that cube up top, that exponent 3 up top. Let's try another one. 3 times 3 times 3 times 3. So that gives me 3 to the 4th. And 3 to the exponent 4 is 81. Now if I want to undo what I just did there, then I would be saying, what is the 4th root of 81? The 4th root of 81 is 3. And that's because 81 is the same thing as writing 3 to the exponent 4. So here's where we get our rule. That fraction, so the denominator of that fraction, is telling me which root I want to talk about. So one of the things I've posted for you guys is this really handy table. And this really handy table is going to help us a lot. So you can see that for any base, so I just did base 3 a bunch of times. 3 to the exponent 1 is 3. 3 to the exponent 2 is 9. 3 to the exponent 3 is 27. 3 to the exponent 4 is 81. So now I can go backwards. 4th root of 81 is 3. 3rd root of 27 is 3. Square root of 9 is 3. So this handy dandy little table is going to help me go forwards and backwards really nicely. So if I want to say the 6th root of 729, that's 3. Okay. Let's do some practice with this. I think that's maybe a good idea. Okay, let's put this into action, do a few examples. So if I asked you 49 to the 1/2, what does that even mean? If I want to write it in radical form, then the 2 is my root, and the 49 goes underneath. So that's writing it in radical form. And then if I want to evaluate, then we figure out what that is. So the square root of 49, we all know, is 7. Okay, simple enough. What if we decided to pick an example of a b? Let's say the 5th root of 32. So I would have 32 to the 1/5. So if I write that in radical form, then that is 5 root 32. That's a 5. And the 5th root of 32, so we get our handy dandy little table. So the 5th root of 32 is 2. Okay. Equals 2. Let's do a few more. A, B, C. Let's do, let's do a seventh root. So let's say 1, 6, 3, 8, 4. Oh, that's such a big number. To the 1 over 7. So that is the same thing as saying the seventh root of 1, 6, 3, 8, 4. Handy dandy little table. I highly recommend you write it out. Seventh root of 16,384 is 4. So that equals 4. Good. Okay, let's keep going with our examples. So still we want to write them in a radical form and then evaluate. So here I have a negative as my base for my exponent 1 over 3. So that 3 is telling me I want the third root of negative 8. Third root of negative 8 is going to give me negative 2, because 2 to the exponent 3 would give me 8, and it has to be negative to give me that negative answer underneath. Okay, that number underneath the root sign, we haven't talked about that. That has a name. That is called the radicand. And this root symbol, when I have things under these root symbols, these are called radicals. So when I say radical form, that's what I mean, is I need this root. Okay, we maybe should have talked about that. All right, let's do some more examples. So there's A, let's see, B, let's say, 10,000 to the exponent 4. So in radical form, so that means I want that root sign. I get the 4 root 10,000. 1, 2, 3, 4 zeros to exponent 4. So that means it's 10. Okay, so we're doing pretty good. That's not bad. Let's do one that's got a little bit more complicated. Let's bring in, let's say, I don't know, 25 to the exponent negative 1/2. So let's bring in that we now have a negative rule in here. That's okay, we can handle it. Let's first get rid of that negative. So the negative, remember, means 1 over. And then that turns my exponent positive. So I have 25 to the 1/2 equals 1 over square root of 25. And the square root of 25 is 1 over 5. Okay, so we can combine things like the negatives in here, no problem. So that's a good example to look at. Let's look at some more. So now this is going to take us to rule 9, which is our last rule for all of our exponent laws. Okay, and what I'm going to do is I'm going to take that base with my fraction exponent and I'm going to give it a different numerator, so something that's not 1. Well, that's okay. We can figure this one out. So that n in the denominator is still code for something over b, and then that m is just on the outside. So it's everything is to the exponent m is one way to write it. We could also write it in on the b as well. That works too. So I have my nth root of b to the exponent m. So you might see it under the root. You might see it outside the root. It means the same thing. Okay, so let's do some examples with rule 9. So if I said, what example am I on? Example 4? Sure, let's say it's example 4. Let's do 27 to the exponent. See, well, I know it's got a third root, so let's give it a 4 up top. Sure, why not? So when I write this out in radical form, so I want it in radical form. To do that, I have to take that 3 and put it in my root of 27. And I always like to do that part first before I calculate anything to the upper exponent. It just makes life so much easier because then you're dealing with littler numbers. So I'm going to take my big number. When I take the cubic root, I'm going to make it smaller. and then I can worry about making it bigger. So radical form is what I did to here. And now what we want to do is now we want to evaluate. So I'm going to evaluate my cubic root first. So handy dandy table. Third root of 27 is 3. Good. So that equals 3, and that's still all to the exponent 4. And then 3 to the exponent 4, let's get out that handy dandy table again. 3 to the exponent 4 is 81. So there's my answer, 81. Ta-da! Okay, you don't have to do it in this order, you can do it in the other order, but then you're dealing with really big numbers, and that's a huge pain. So I generally do the root first. You don't have to. Okay, let's do another example. So that's A. So B, same kind of question. Let's say, ooh, what if I said 16 to the exponent negative 0.75? What in the world? We're just wrapping our head around fractions and I'm throwing you decimals. What am I thinking? Well, let's make that a decimal, shall we? Or a fraction, I mean. Shall we? Yeah? Okay. So 0.75. Well, that's the same thing as 3/4, right? I got 75 cents. That's just 3/4. Okay. Let's do that first. Otherwise, it might get a little complicated looking. So this is all to the negative 3/4. Okay. Let's take care of that negative first, because that's going to be the most awkward. So that means it's going to become a fraction. So 1/16 to the 3/4. Okay. Now let's write it in my root form. So my radical would be 1/4 root of 16 all to the exponent 3. All right, let's keep going. So that, here, I'll just keep it going up here maybe. That is going to be equal to 1/4 root of 16. Let's think. Let's see here. 4th root 16 is 2. So that's 1/2 all to the exponent 3. And then 2 to the exponent 3 is just 8. So there's my answer. All of that to get 1/8. Okay, let's do a few more examples. So your textbook doesn't have a whole lot of really good examples, so let's add this one in. I'm just guessing that we're at example 5. I don't really know. But this is just like your question number 2 in the homework. So the question is worded, write in exponential form, then evaluate, express answers in rational form. So rational form just means, remember, rational is another word for fraction. So that means no decimals. No decimals. Sorry. Okay. So let's try a few. Oh, let's do maybe the 5th root of 243. So the 5th root of 243, let's write that in exponent form. So because it's a root, I want to write that with my number. So my radicand becomes my base. And that 5 becomes a fraction up in the exponent, so 1/5. Then I want to evaluate, so remember, bring up your really cool table. So the 5th root of, let's see, what did I say, 243 is 3. Oh, good. Okay. So that answer would be 3. So I wrote it in exponent form here, and then I evaluated. And I don't have to worry about fraction form because, 3 is 3. All right, let's try another one. How's about we do the 3rd root of 343. And that's all to the exponent, 4. Sure, why not? Well, I got a lot of 3's and 4's in that one. So the 3rd root means that my exponent's going to have a fraction with the 3 in the denominator. and everything's to the exponent 4, so I'm going to put that one up top. Now, I actually find this far more clunky when I go to evaluate, unless I'm typing it into a calculator, in which case it's a whole lot easier. If you type it in the calculator, make sure you put your exponent in brackets if you do it all in one step. So let's recap here. Third root of 343, so where's that? 343, there it is 7. Good. So this equals 7 to the exponent 4, and 7 to the exponent 4, come on back. 7 to the exponent 4 is 2401. So that equals 2401. So there's my answer. Okay, so let's do another complicated example. So same question, write in exponent form, then evaluate, keep it as a fraction. All right, well this 7th root out here, remember, means that I'm going to write everything to the exponent 1 over 7. So in this case, that's the negative 2, 1, 8, 7, all over 1, 6, 3, 8, 4. And our rules from before means that that 7th, that 1 over 7 comes in and hits both of them. This also says I'm doing the 7th root of each one. I'm allowed to do an odd root of a negative number. My answer is going to come out negative. So when I go to evaluate, let's bring up our lovely little handy dandy table. And 7th root of 2187 is 3. So my answer is going to give me negative 3 over 16384. Well, the 7th root of that is 4. So my fraction answer in this question is negative 3 over 4. Okay, let's do maybe one more, and then we'll call it good for the day. So let's say I have something, let's do a complicated one. Let's put a couple of things together. 7776. 5th root of 7776, all to the exponent, I don't know, 8. Sure. So this one's just going to bring into play the fact that I now have that other one. So that takes me up to rule 9 again. So I'm just going to apply that, and then we're good. So to write this in exponent form, so that 5 has to become a fraction. So 7776. 5 is the fraction in the exponent. The 8 stays up top because I'm multiplying, or I'm not multiplying. Well, yeah, I guess you are. Okay, so the 5th root of 776, remember, is, let's see, 5th root is there. There is 776. So that's of 6. So that gives me 6 to the exponent 8. And 6 to the exponent 8, let's look that back up. 6 to the exponent 8 is, oh, that's a big number. 1, 6, 7, 9, 6, 1, 6. Holy cow. Well, that's the thing about exponents. They get really big, really fast. Okay, good luck with your homework.